Hi guys, we're going to look at solving absolute value inequalities. So the first thing to do is to get the absolute value by itself on one side. Then we're going to undo the absolute value by dropping the absolute value signs, and then we split the inside part to be a positive and a negative. Then we need to solve each, and then we write our statement. So just a couple things to remember. Open dots are represented without the equal sign. Closed dots are with the equal sign. And then if you multiply or divide by a negative, you need to flip the inequality sign. All right. So first off, we're going to solve these algebraically and then write the solution. So, all right. So step one, is the absolute value in this inequality, by itself on one side? Yes. So what we can do is drop the absolute value signs and split into two different inequalities. So n over 5 is less than or equal to 3. And then the second one, these are parentheses, not absolute value signs. The second one, n over 5 times a negative is less than or equal to 3. All right, so I'm going to go ahead and multiply by 5. Multiply by 5. 5 divided by 5 is 1, so I get n is less than or equal to 15. Second, I'm going to multiply by a negative 1 to cancel out that 1, so multiply by a negative 1. So I get n over 5 is less than or equal to negative 3. And then I'm going to multiply by 5 on both sides. I get, I've messed up. If you multiply by a negative here, like this, what do you do to the sign? The sign is going to flip. So instead of becoming a less than, it's a greater than. So I get n is greater than or equal to negative 15. On my number line, I'm going to put a 0. I'm going to count up by 5. So 5, 10, 15, negative 5, negative 10, negative 15. Do I use an open circle or a closed circle? I used a closed because of the equal sign. And then at 15, I also use a closed circle. So my values are that on the blue one here, the values are less than 15. And on the green one over here, they're greater than negative 15. And it looks like I created a sandwich. So I'm going to erase up to here and say that my solution set is in the middle. So I have to be greater than negative 15 and less than 15. We write it like this. N is greater than negative 15 and less than 15 because it's an and statement. Okay. All right. Up next, is the absolute value by itself on one side? Yes. So take the inside. 4 minus 2w in parentheses is greater than 12. And then my second equation is 4 minus 2w is greater than 12 again, but we make the inside stuff negative. So I'm going to go ahead and solve. I'm going to subtract 4 from both sides. Get negative 2w is greater than 8. Then divide by a negative 2. I get negative 4 on this side. I divided by a negative, so I'm going to switch the sign. All right, up next, I'm going to multiply by a negative, which gives me 4 minus 2w is less than negative 12. Flips the sign. Subtract 4. So I get negative 2w is less than negative 16. Do I flip the sign? No, because you're not multiplying, you're adding or subtracting. Then I'm going to divide by negative 2. I'm dividing by a negative, so I switch the sign back. W has to be greater than 8, and W has to be less than negative 4. So I'm going to start with my 0, count it by 2, 4, 6, 8, negative 2, negative 4, negative 6. At 8, I use an open circle, and it says greater than, so I go to the right. For this one, open circle at the boundary point at -4 and to the left. So are we both of these values are split apart, so this is an or statement. We just say W has to be less than -4 or W has to be greater than 8. All right, next one. Is the inequality by itself? The absolute value by itself? Yes. So on this side, we have the absolute value by itself, so we can go ahead and drop the signs. The inside part, -3n, can be equal to 3 or greater than or equal to 3. I'm going to go ahead and write the inside part over here, but then remember you have to make the inside part negative. So I'm just going to go ahead and simplify. I'm going to start with the purple. So a -1 times -3n is a positive 3n, and that's greater than 3. I didn't multiply negative by both sides. I only multiplied it right here on one side, so I didn't need to flip the sign. Now I'm going to divide by positive 3, so n has to be greater than or equal to 1. I'm going to go ahead and draw that in right now. Okay, close dot, greater than or equal to 1. All right, in the green, -3n is greater than 3, so I'm going to divide by -3. Look here, I'm dividing by a negative, so I'm going to go ahead and flip the sign. 3 divided by -3 is -1, and so n has to be less than -1. So less than or equal to. So I'm going to go to -1, give myself a closed dot. Less than is to the left. Is this an and or an or statement? This is an or because I can't be in both locations at the same time. So W has to be less than or equal to -1, or, sorry, N, that's an N. N has to be less than or equal to -1, or N has to be greater than or equal to 1. All right. Is the absolute value by itself? No. So we're going to start by subtracting -5 from both sides. So the absolute value of x has to be less than 9 minus 5 is 4. Now is the absolute value by itself? Yes, on one side. So go ahead, to undo the absolute value, we split this into the inside, x is less than 4, and then the opposite of the inside is less than 4. So this one's solved, x has to be less than 4. This one we need to get the purple here. We need to get x by itself. So I'm going to divide by -1. So the sign is going to flip. I get x is greater than -4. So 0, 1, 2, 3, 4, -1, 2, -4. Okay. So x has to be less than 4. And x has to be greater than -4. These are going to intersect. So we're going to have a sandwich situation. This is an and. So x has to be less than 4, but greater than -4. All right, last one. The absolute value of 2x is less than -7. Well, because we have the absolute value by itself and you can't take the absolute value and get a negative number, this is no solution. So what kind of numbers could I plug in for x? Nothing to get a negative. And that's it for today.